How you came up into this book writing stuff? You are the creator of Plans as 2. That's what it is, and why there is a 2 as well with it. Your definition of ROS2, how do you look at ROS2 coming from ROS1 to ROS2? And there have been a lot of things, as you ever mentioned. How do you feel about this and how it has impacted robotics development? So how do you think how the starter should approach it? How one who is starting in robotics should get into ROS?
ROS is not robotics. So you have to learn robotics. You have to master that. People say, oh, my software is not working because you develop one part and it works, you develop another part. But when you run it together, it started to crash everything.
Starters, they are just learning ROS2 and they want to contribute into it to get more commits and stuff like that.
I think the people who want to contribute to ROS2, of course, they have to learn. For example, you are working in a company in navigation, go to Nav2. If you are working in manipulate, go to movie 2. If you like computer science, go to RCL CPP to see if you can head there.
So you have organized Robo-cup. What's the future of Robo-cup? How it is heading?
Many people think that navigation is solved, but no, it's not solved.
Today, we have a very special guest with us, a full professor at University of Juan Carlos University in Madrid, Spain, and he has been teaching robotics for the past 2 decades. It's a lot to uncover from here. Hello, Francisco. How are you?
Hello, I'm fine. And you?
I'm good. I have been going through your book, and it's been 2 to 3 months. I have been just touching some chapters and getting back to development because I am into education side as well. But that's an amazing book, and very few books are with such detail. How you came up into this book writing stuff, from research into this book writing, when you have also understanding of the software architecture, bringing it to the book as well?
Yeah, I started that book because there was a call for authors in another book called Making Robot Works that was pushed by Steve Masinski and Michele. And I wrote one book only for introduction of ROS2. But that book had no success, and I started writing this book starting from that chapter. This book is trying to give some background, some introduction to the programming with ROS2. Actually, tomorrow I have to deliver the second edition to the editorial. I'm finishing reviewing, and we will have 2 additional chapters. Yes.
That's great. I was going through your work and find out that you are the creator of Plans as 2. So as a professor, and it's a developer side of a professor as well, how you came around this Plans as, what it is? Tell us more about this Plans as and why there is a 2 as well with it.
Yeah, we participate in the research part of my task, participating in the Robo-cup. In those years, I was using ROSplan. ROSplan is a middleware for symbolic planning for ROS1. And when ROS2 appeared, I tested if they had plans to go to ROS2, but they hadn't planned. So I needed something. I was seeing some things, but I decided to implement my own successor of ROSplan in ROS2. And I took the opportunity to fix some bugs and some things I didn't like of ROSplan. And I think Plans is a great software. It's easy to integrate in the team of the Robo-cup. Many people has started to use it. For example, in the last ROSCOM, people from a company in Italy was using Plansys 2 in the fleet of robots, and also Plansys 2 is in the Astrobi robots in the National Space Station. So I'm very happy with the history of Plansys 2. I think it has been a very successful software. It's very useful, and I try to maintain as best as I can. I am also maintainer of a lot of other packages. I'm running out of time to maintain, but I try.
Yes, definitely the open source gets this hit that we don't have much time to support this software, but still it sounds great. I'll look into it. Coming to the part of robotics and the tools in robotics, ROS2 is the most popular one to utilize it. I want to know about your definition of ROS2. How do you look at ROS2 from robotics and research perspective? How do you define it?
ROS2 is a framework. It's an ecosystem. It's many things. There has been a lot of middleware before ROS. Carmen, Planet States, YARP, Maybe many of them are better than ROS, but the good thing, the strength of ROS is the community. A vast amount of developers that develop a lot of software, not only users, also organization, companies, manufacturers. That's very important because when you develop a middleware, the problem is having the drivers for the sensor and for the actuators. So if you have your own middleware, you are wasting a lot of time trying to incorporate new hardware to the middleware. In ROS, you don't have that problem because probably someone has done before your driver or the manufacturer has done for you. It's an advantage because at final, ROS now is a standard in robotic programming.
And looking at the journey you had, you have seen ROS evolving, coming from ROS 1 to ROS 2, and there have been a lot of things, as you ever mentioned. ROS planning was one interesting thing that you are trying to continue. How do you feel about this, and how it has impacted robotics development from ROS 1 to ROS 2? And also
Yeah,
the cons of it, if you have any.
the impact of the changes are very big. For example, when I started with ROS, it was the change from ROSville to Catkin, and it was a great change. Another big change went from Python 2 to Python 3. That also was a big effort for the community to adapt. But the change from ROS 1 to ROS 2 is great. It's very hard because it's a break. It's a break, and many people has not migrated yet to ROS 2 because the change is very big. But the advantage are also very big because you have a better build system, you have a better design. You are in the time getting many of the software you have in ROS 1 because now ROS 1 has more software than ROS 2. But many people are starting to migrate or trying to replicate the software in ROS 1 that was in ROS 1 to ROS 2. The chain is conceptual is very big. The greatest chain, I think, that the only thing is worst is maybe the reliability in the network layer. But we are working hard. I know that the DDS vendors are working very hard. We will see what happens with them.
Let's see. So, as the system is growing, they're accepting good practices. With that, there comes one offset, and that is it becomes more hard to understand if someone is getting into it. A new beginner, they get into things, and the structure is so organized that they are barely even good at programming, and this structure makes them fear of getting into this tool. So how do you think how the starter should approach it, how one who is starting in robotics should get into ROS?
Well, the first thing is ROS is not robotics. So you have to learn robotics is your main focus if you want to be a great robotics engineer. But you need ROS because it's a framework that can make your dreams come true. Actually, don't reinventing the wheel. For that reason, you have to master that because you can't be in the situation in which you can't apply some theory, some approach. You are limited by your knowledge in the programming language or in ROS. So you have to learn it and master it. Master it from the bottom. My approach to teach, for example, to teach ROS is going from the foundation, from the bottom, and starting to write your own code, trying to see what it happens, change things to see what is happening with that chain, and trying to have full control of what is happening below the level of the application. So I think that is the way you have to approach to ROS. And of course, trying many software, many third-party software, learning to use another software because there are many people who are not able to use the software of another people. So you have to open your mind and try to collaborate. I think the key here in the open source robotics community is collaboration.
Yes, definitely. Looking at the research side of robotics, um, ROS has helped a lot because we can do a good research, put it in a package, and other researchers can obtain it, work on it. From your research perspective, how has ROS helped you in going in more detail than just getting the packages? How has it helped you to do more research, grow in the research in robotics?
Yeah, it has a lot of impact because in research, when you develop an algorithm, it's critical to have a baseline, to have another implementation to compare with. And before us, it was very difficult because you had to read the paper and develop again that software, or use maybe a free library, but it was hard to replicate. Now with ROS is easy. It's easy. For example, I was doing things with localization at SLAM, research about that, and I have a lot of packages that implement SLAM or implement localization algorithm, and you can run it and compare with that. Actually, for that, the ROS2 tool is critical for us because you can teleoperate your robot or record all the information, all the sensory information, and after that run with the same data with different algorithms and compare them. So that's very important. And another thing is every time I write a paper, I try to do or in the same repo or in a parallel repo, a way to replicate our work for the reviewers. For the reviewers and the people who wants to use your software. Taking advantage of ROS is a standard, it's easier now to provide this software to another researcher to try your software. So it's important to ROS in that way. It has a lot of impact. Yeah.
Okay, interesting. So, looking toward the teaching styles, there is robotics theory, there is research, and then there is software development. So, what do you think should be the structure for a person getting into it as a researcher?
As a researcher, more or less the same. You have to master the programming languages, to master ROS in that case, because in particular in the research, you have to develop your algorithm and you have to make it work in real robot. So it's important to be able to do it, not only to test probably algorithms in MATLAB, you have to make it work.
You have spent a lot of time in research in your career. Your main core areas are planning and cognition systems. So, what do you see the next challenges coming inside of planning? Because a lot of work has been produced. So, in the next phase, what do you see coming for planning in the research directions?
Now, large language models and the foundational models will have a lot of impact in all the robotics, and in particular in the planning, because until now we were using PDDL, planner for PDDL. I suppose it will continue, but many people are researching in making those large language model or foundational model to create plans, to evaluate the plans and to do replanning in a more smart way. These techniques, these algorithms, these new trends will be in mobile robotics, in cognitive, in whatever aspect of the robotics. This will be a very powerful tool for the next years.
So, sort of AI based decisions on available planners that we have. Okay. Coming to the part of AI stuff into robotics, we have seen industries are using vision based AI systems for segmentation and object detections. Uh, are these companies, the actual companies of robotics, also using AI in planning side, or it's they are just using the algorithms and tweaking them?
Well, deep learning is being used for the industry for a long time because they are reliable.
Okay.
Detecting person, detecting objects, or segmenting an image is very robust. But the new techniques of artificial intelligence are not so robust. So many models hallucinate, and I think you can't make a business model in something that is not completely reliable. Well, it's something not very critical. You can do it.
Okay. So, coming to the part of your teaching experience, you have been teaching software architecture of robotics. When we look at software architecture, whenever we search online or read some books, we always find it is oriented towards web application, Android application. This hardware oriented stuff, a lot, very less content is available. So, if someone wants to learn about software architecture, what is the direction he should take and look into things or books and people he should be looking at?
Yeah, you are right. You are right. The software architecture for robotics, there are few resources. When I started this course, I found very few resources to prepare this, because when you see for software architecture, you are starting to see a lot of content for backend, internet systems, but not for robots. Because I think the software for robots for many years has been more handcrafted. It's hard to extract general conclusion from the history, from the previous experience. In my courses, I teach mainly the use of the middleware and how to organize the processes, how to organize the nodes, how to integrate new software, how to deal with some usual things like, for example, the geometric transformations to incorporate to your software, how to incorporate navigation, perception, and so on. So how to organize your software. And this year I will also introduce something about real time, because real time is something that the people that program in ROS, I think many don't take care about that aspect. People say, "Oh, my software is not working," because you develop one part and it works. You develop another part, but when you run it together, it started to crash everything. And it's because when you stress your system, the things don't work as you expected. So you need a step to see, oh, what part is critical. That part you have to put apart, and this is a real-time part. These kind of things I teach in my course of software architecture.
Okay, that's great. Looking at the characteristic of a person, a researcher, what do you think about it? What robotics researcher from software aspect should have the characteristics looking towards the problems of robotics, because a lot of advancement is happening at a very fast pace. So how new researcher should look towards these problem and how to find them and then research about them?
I have not a clear response about that. You have to read a lot. You are a researcher, a part of the practice and learning in the technical part, you have to read a lot, be up to date with the new research in order to find your way to push a little bit these limits of the knowledge for your thesis. But it's hard to say some
Okay.
aspect.
A very core problem with contribution to ROS2. Starters, they are just learning ROS2 and they want to contribute into it to get more commits and stuff like that. But for just committing into ROS2, the problem is we have to understand the whole system into it. There are the issues are not very simple. They require a lot of understanding. But when people start working in companies, they don't have time to commit or contribute to ROS2. So in that scenario, how does ROS maintains this whole system or ecosystem of contributing? Is it sort of paid on certain scenarios, or it's just people doing it by volunteering?
We are talking about the core packages of ROS2 that are maintained with the people that works in Intrinsic, the formers in the Open Source Robotics Foundation, and they, I don't know if they are direct paid for that
Okay.
or they have another duties, but the fact is they are there and they are helping the people with the part of contribution. I think the people who want to contribute to ROS2, of course, they have to learn. They have to have the open mind. They have to focus in the package they are interested. For example, you are working in a company in navigation, go to Nav2 to see if you can contribute there. If you are working in manipulate, go to movie 2. Or if you like computer science, go to RCL CPP to see if you can help there. In those repositories, many times the maintainer has labeled the issues with very good first issue, help wanted. I think they can start there. They can start there. Of course, the first pull request will be a mess, and the maintainer will try to help. This is another message for the maintainers. So be kind. Be kind, because nobody born with all the knowledge. So help the people that come after you, because they could be very good maintainers in the future. So if you are a new contributor, you have to keep pushing, find your place to help the community.
Nice. So as you mentioned, there is Nav2, there is Move2. What are the main stacks that connect with ROS2 ecosystem? And they are doing good products. They are building robotics software, amazing. Can you give brief description of these and what the characteristics of these ROS software stacks that connect with ROS2?
Well, the core in ROS2 are the client libraries. The client libraries are very important. The official are the Python and C++, but maybe the C++ is where more people are working. The main packages probably are those, because in mobile robotics, moving a robot is very important. So nav2 is very important. For a new contributor, is a good software to see good practices in robotics. So I see for moving nav2, for manipulate is move it too. I'm not expert in manipulation, but I have used it a couple of times. If you don't use nav2 or you don't use move it, you are reinventing the wheel if you have to program, because the effort to do all the tools and all the approaches they have implemented are very hard. And apart of that, for perception, you have the YOLO ROS. For the dialogue, you have Whisper and Whisper ROS. So with these two packages, you can have a lot of resources to human-robot interaction. Also, Power Robotics is doing the HLI for ROS. It's a package for a complete suite to interact with people, with human-robot interaction. And a part of that, I think they are not mainstream packages. For planning, of course, Plus is two. Also for task, we have the behavior trees. Behavior trees has a lot of success in the last times. Many industries are using this approach. It has a lot of advantage with respect to the finite state machines. But finite state machine, you have use cases for that. But maybe for control, for high frequency control or for task, it's better to do the behavior trees. We have good libraries, for example, the libraries from Davide Faconti, behavior tree CPP, and you have another.
Interesting. From research perspective, who are the top researchers in planning side of robotics that you admire and you recommend people to look their work and also study these specific researchers and their work?
Well, of course, one of my main books is Probabilistic Robotics. So
Yes.
probably Peter Fox, Purgar are good example of good researchers.
Okay. How do you see robotics evolving in the next decade, and what role will tools like ROS2 play in the shaping this evolution?
Mainly giving importance to the standardization of the software. I think it has a lot of impact in the evolution of robotics because it has solved many things in the part of software. In the part of hardware, I think we are living of the evolution of the robots with the cheaper robots, smarter robots, and of course the ROS will be in the center of that, joining and integrating the work of the manufacturers with the work of the researchers.
Oh, that's great. That's great. The future directions of robotics and planning that you mentioned are going to be towards LLM and integration of language models with the current algorithms, and then they have to decide what is appropriate for now. That's a good direction. And people starting with people who are just starting out, what do you think they should be focusing on getting into mobile robotics? What they should look towards? Because as a researcher, nothing is much clear as a starter in any field. So what do you recommend people to directly get started into it?
Depends on the research group in which you start. It has research line. So maybe you will focus on the research line of your group. Maybe because there are many things to do. Many things to do in human-robot interaction, many things to do in planning, many things to do in navigation. For example, many people think that navigation is solved, but no, it's not solved. For example, the navigation in outdoors or navigation in not planar environments, that is not solved. But there are many places to research nowadays.
There's a whole world ready that you can start researching it. But your suggestion is whichever the group that you are joining, the lab you're joining, work with them in that direction. That would be the best thing they can do as a starter. Okay, so let's say you are hiring some researcher for your specific team. What should be the characteristics? How should he be looking at things? What is your ideal research assistant?
My ideal researcher is a person with proactive. It's a proactive person that do a lot of things apart of what he has to do in their work. Person like to work in their own hobbies, in our own hobbies related to the robotics. People who are autonomous, who are not saying every time what he has to do. I don't know, good person. I think it's important to be a good person to work with.
That's great. That's great. So you have organized Robo-cup. Tell us more about Robo-cup and what's the future of Robo-cup, how it is heading, and what people can learn from it.
Robo-cup is a very important competition. It started in 1997, I think. From that year, it has supposed a great event in robotics, fostering the research in robotics because it presents you a standard scenario where you can apply your algorithms and compare with the algorithms of another researchers. At initial, it was only soccer, and it was soccer because nobody needs to be instructed what is the rules of the test is soccer. A ball, a goal, you have to. But in time, another good leagues has started. For example, the rescue league, or the one we participate now is the at home. The at home, you have domestic scenario in a house in which you have to learn people in that scenario. Help to elder people, help to dependent people. I think having these tests and these test beds is fostering the introduction of robots at home. I think is one of the things we talk about before that we wanted to have robots in our houses.
That's great. That's great. Thank you, Francisco. Thank you for being here, taking time, and giving your experience based answers. And is there anything that you want to tell to the audience?
Thank you to you for inviting me. I will say to the audience to keep working, to work in your hobby by loving what you are doing. So that's my advice.
Thank you. Thank you for your time. And I'm looking forward to the second edition of the book as well.
Thank you very much. Thank you very much.